Okay, so we're going to talk about transformations and how they relate to congruence. So if we look at these two triangles, we might say to ourselves, well, are these two triangles congruent? Well, maybe you could get a ruler or a protractor and measure some sides and measure some angles and try to establish some type of like side angle side criteria. But there are other ways to do it as well, and that's what we're going to be exploring today. So what we're going to do is we're going to improve upon our definition of congruence. Because in a transformation, two figures are said to be congruent if and only if you can map one figure onto the other by using rigid motions. That's our idea here. So what we want to do today is we want to take triangles and show that we can map one triangle onto another, and that's going to establish congruency for them. So if you have that little worksheet that I distributed to you in class today, you're going to need that also. So what we want to first do is take triangle ABC and then map it onto the single prime triangle, its first image, and then map it onto the double prime triangle. So we go from the no primes to the 1 prime and from the 1 prime to the 2 prime. So one thing that I'm thinking about here is an idea called orientation. So the orientation of a figure tells what order the letters go and what order the vertices go in. So when I label like triangle ABC, I'm going in a counterclockwise direction from A to B and to C. What you might notice is that in its image, the one down below, you actually go into a clockwise rotation. So if that orientation is reversed, here's a little hint. If the orientation is reversed, that means a reflection was done. If you have an orientation that's constant, like if you look at the one from the single prime to the double prime, that's a constant one. That hasn't changed. So that would be a clue that you could do a translation or maybe a rotation as well. So that's something we're going to think about when we look for these transformations that we do. So when I'm looking at this one here, I'm thinking, well, how do I map point A down to point A prime? And how do I map B to B prime? Do you remember that we talked a couple days ago about that if you join a segment or the vertex of a segment to its image, or if you create a segment between a vertex and its image after a reflection, that the line of reflection is the perpendicular bisector of that segment? So that's going to give us a little clue here that what we're going to do is we're going to take triangle ABC and we're going to reflect it. So we reflect triangle ABC over the x-axis. And that creates the image triangle, triangle A prime, B prime, C prime. Now let's go from that triangle to the next one as well. The orientation is consistent between them, so you can kind of tell that there's like a translation going on. So maybe if I go over to the left 1, 2, 3, 4, 5, 6 boxes, and then up 3, it seems like that's going to be the way to go on each of these, is to go the left 6 and up 3. So then afterwards, we're going to translate the image of the first triangle, triangle A prime, B prime, C prime, and we're going to translate it to the left 6 and up 3. And that's going to result in the double prime triangle. So that's our idea that we do here is we start at one triangle, we figure out how do we get to the next one. So let's move on to our second one. Take a minute, see if you can go from triangle ABC to its image, the single prime, and then to its double image. So as I'm looking at this, I'm trying to think about this orientation here because the orientation was kind of helpful. If I notice, my orientation is still a clockwise movement, and in the image of it, it still is clockwise. But can you tell that it looks like, even though it's a clockwise orientation, that the image triangle was rotated somehow. So that's a little tip as well, that there's probably a rotation going on here. One thing that might be helpful to do, let's see, can I move this around? So if you think about turning your graph paper a little bit, I'm looking at where triangle ABC originally is. If you turn your paper, can you tell that it kind of goes to where the image triangle was before? It looks like I'm rotating around the origin. So maybe what I'm doing here is I'm going to be rotating triangle ABC. Now in a rotation, you have to tell the degree of the rotation, 90 degrees. We have to tell the direction that we're going in. We're going counterclockwise. And we have to tell where we're rotating about. So we're rotating it about the origin, the point 0, 0. And that's going to map to the single prime triangle. Now to find the transformation that gets us to the double prime triangle. It looks like the orientation is reversed. And as I'm looking at it, it seems like they're on the same horizontal line. So if I draw one of those segments joining a point in its image and look for its perpendicular bisector, it looks like this segment that I drew in green is 6 units long. So if I go to 3 units and draw the perpendicular bisector of that, it looks like that's where that line's going to be. So that's going to be the equation x equals 2. So then what we're going to do is we're going to reflect the single prime triangle over the line x equals 2. And that's going to map to the other one. So that tells us, because we have rigid motions that map triangle ABC eventually onto A double prime, B double prime, C double prime, that those two triangles are congruent. So let's go to one last one. So you might be saying to yourself, oh no, there's only 2 triangles. Well, you might be able to find a transformation that maps triangle ABC onto the double image, the double prime triangle. There might be a way you can find that out. If not, try to look for an intermediate point, like a starting point. Try to figure out, is there a transformation that I could do to the original triangle ABC to get to a single prime triangle first? So maybe what I'm going to do is I'm going to go from ABC to triangle A prime, B prime, C prime. And then from there, I'm going to go to triangle A double prime, B double prime, C double prime. Play for a minute with that. See if you can come up with a transformation that does that. Alrighty, so as I look at this, one thing I notice is that my orientation from my original to where I want to end up is a reversed orientation. So I know there's a reflection going on somewhere. So maybe what I'll do is I'll start by doing a reflection. And I think that after I do a reflection, I might be able to move it in the right direction. So it doesn't really matter what line you reflect over, I think. I'm going to take one that makes it kind of easy to see. I'm thinking if I draw this line here, a reflection over the line y equals 2. It's going to map B to itself. So here's going to be where like point B prime is. It's going to move A prime down 2 below it. So A prime is going to go here. And it's going to move C prime. Let's see, point C is 1, 2, 3, 4, 5 units above the line y equals 2. So if I go 5 units below it, that's where C prime is going to be. So now if I take that triangle, can I then do a translation? I think that would work pretty well. So let's see if we can summarize that. So I'm going to reflect triangle ABC over the line y equals 2 to get what I've drawn in as triangle A prime, B prime, C prime. And then it looks like I'm going to do a translation of that one. I'm going to translate the image triangle by moving it to the right 2 units and then down 2 units. And then that's going to map onto the other triangle. Now, is that the only transformations you could have done? Probably not. There's a lot of other ones you can do. So this is one example of many. If you found a different one, hey, good for you. Fantastic.